line, so it's not very interesting of a graph, but just kind of want you to see like the thought process. I'm actually doing this in honors trigger free calc right now as well, so it's kind of weird that I'm doing it at the same time with you guys and my honors trigger free calc class, but they forgot it. And I told them, I'm like, I'm doing this right now in honors algebra too, and they're like, oh, yeah, maybe we remember. So you'll see this stuff again next year. And you'll see it in AP Calc when you get there, so it's not going to go away too easily. But if you look at the directions, it says let f of x equals x plus 2. Sketch f of x and then sketch the function y, given the transformation to f of x. So if you look at number 20, just start at this one and then we'll look at 24. The first thing you're asked is to sketch f of x. And that's this equation, f of x equals x plus 2, or you could say y equals x plus 2. Either one. How do you sketch that graph? So y equals x plus 2. How would you sketch that? What would you do to graph it? Connor, what would you do to graph it?
Just a straight line with a slope of 1 and a y-intercept of 2.
Good. So he said straight line, slope of 1, y-intercept of 2. So it starts up at 2, rise over run. And there would be a sketch of the line. So then, as we did in class, 3 ordered pairs from that line, because I want to see those 3 ordered pairs and the transformation to those 3 ordered pairs. So it doesn't matter which 3 you choose, just pick 3. So maybe I'll pick this one here at -2, 0. This one is at 0, +2, and then maybe I'll pick this one up here. So that's 3, 1, 2, 3, 4, 5. 3, 5. So that's the current line that they asked you to graph. So then it says y equals f of x minus 2. And I want you to kind of think about what the transformation would be if you have in parentheses x minus 2. How does that graph move? Julian? So not down to because it's not outside of the function. So this moves up to because it's outside of the f of x. So instead, yeah, this moves right to. The minus sign is part of the equation. So this part here is like standard form of the equation. This +2 tells us the graph should move to the right. So if the graph moves to the right, that means you're taking x and adding 2 to that value. The y stays the same. So if I'm taking x and adding 2, my new point is 0, 0. We then have 2, 2. Adding 2, this makes 5, 5. So shift right 2. And here's the new line. Now that one you probably could have just literally taken your point and shifted it to the right 2, each one of those points to the right 2. But again, I want to see a little bit of work. Like what's the thought process? What are the new ordered pairs that you're creating? Any questions? So if you go down to number 24, we're going to do the same thing with number 24. So again, I'm going to go back and graph that original line, which was up at 2, slope is 1. So there's the original line. Picking 3 points from that original line. So maybe I'll pick this one over here, just picking different points. So that's -4, -2. I can pick -2, 0 again, and then I'll pick 0, +2. So in 24, there are 3 different values. So there's a -1, there's a plus sign, and then there's also an x minus 1. So there's this negative here. That really is like having a -1. We have the x minus 1 inside, and then we have that +3. So 3 different things happening. Maggie, can you tell me anything that's going on with this function? Like, how would it move?
It's gonna be below.
Okay, so the negative part makes it flip. So the -1 in front makes the graph flip. What else happens with this graph besides flipping? Maggie, do you know what else happens?
Does it go right one?
Yep, it moves right 1. And up 3. So 3 things that's going on. Inside, that moves right. The outside plus 3 moves it up. And then the negative in front is flipping it over the x-axis. So I'm going to try and write a little pattern for us to follow based off of all this information. And the first thing, if it's moving right 1, that changes x. So that means all my x values need to be shifted to the right, which means I'm really adding 1 to x if I'm shifting things to the right. If the graph is flipping over the y or the x-axis, if it flips, that means the y becomes negative because it says negative in front of f. So you're really taking negative y or negative f of x. And then we also need to add 3 to shift it up. Anything you're doing vertically is affecting the y. So if I wanted to write a little pattern, I have x plus 1 because my x values need to move to the right one. And then negative y, because if f is negative, f and y mean the same thing. F of x and y are the same exact variable. They're interchangeable. We're just writing them differently. And then plus 3 is moving the graph up 3, which means I have to take the y value and move it up 3. So we're going to try and apply that to the 3 points. And I just picked these 3 points. You could have picked 3 different points. So I currently have -4. Well, if we add 1 to that, it becomes -3. So that's my new x value. And then the -2 becomes negative. Well, it's already negative, so now it's positive. And then we're adding 3 to it, so that becomes a 5. So my -4, -2 is now 3, -3, 5. The next one, I have a -2. Adding 1 makes it a -1. And then it says 0. Well, -0 doesn't really change anything, but plus 3 makes that point at 3. And then finally the last one, we have a 0. Plus 1 is 1. There's a 2 here, so we're making it negative. So now it's -2 plus 3, so that's going to become a +1. So you may not have chosen the 3 points that I did, but that's how my 3 points would change, transform, translate, whatever word you want to use there. And then plotting these 3 points. So the graph should flip directions. If it was positive, it's now a negative graph, and that's because we multiplied the y by a -1. Our graph also has moved up besides flipping, and it shifted to the right. Questions? So what I would like you to do is if you can go right next to it to number 23. You didn't have to do number 23, but I'd like you to just see if you can try and write the pattern. So this right here is what I consider the pattern. So what's going on with this problem? How is it translating? Graph the original, pick a couple of points from the original, and let's see if we can come up with a new graph. So I know you didn't have to do 23, but just to get you to practice a problem, bless you. See if you can squeeze 23 in there somewhere. Make sure you notice that it is counting by 2s just when you go to grab those points. So you're going up 2 and then rise over run, up 1 over 1, up 1 over 1. Melanie, question?
I'm not really confused.
So that number is in front of F is X2. So you're gonna take 3 times Y. That is also Y. So both of them are changing Y. Because this is stretching the graph vertically, that makes the graph smoother. This is moving it up. So one's stretching it, the other one's moving it up. Being stretched. Yep, that's exactly the same. Yep. Emma, what 3 points did you pick from the line for 23?
0, 2, 1, 3.
Okay, so 0, 2, you said 1, 3, and 2, 4? So Emma chose 3 points that are right in a row, really tiny right here. Those are the 3 points she chose. You didn't have to pick those 3 points, so you could pick points that are a little more spread apart. So you could pick -2, 0. You could pick 0, 2, and 2, 4, 4, 6 up there. You don't have to choose those 3 points. She just picked 3 points that are really close together. And then when you're looking at the problem, the 3 is in front of F. That's the same thing as saying take 3 times Y. The -1 is also with the Y. So 2 things are affecting Y. So we have 3Y minus 1. The X, well this graph, it says +2, but that really means we have an X minus -2. So the graph is really moving to the left. So our X values need to be subtracting 2 from them. So we have X minus 2 and then 3Y minus 1. So Emma, what would the new points be since you chose those 3 points? What are your new 3 points?
-2, 5, -1, 8, and 0.
And then you said 0, 11. So those are Emma's 3 new points. So subtracting 2 from X, each time subtracting 2, taking the Y value, multiplying it by 3, and then subtracting 1. Multiplying by 3, subtracting 1. Multiplying by 3, subtracting 1. And then plotting those points. So -2, 5. Remember, it's counting by 2's. So the steepness of the line has changed. It's now a steeper line, and you can see that like graphically. So it definitely is more vertical than the original one we graphed. It's also moved to the left. The shifting up part is kind of hard to like see, but it has also shifted up. Questions? Are there any other questions on the homework? So I would like you to pass that forward, please. Today we're going to kind of look at graphs instead of make our own graphs. We're going to analyze those graphs. Talking about the domain and the range of the graph. So we're not in the packet today. I have a separate little packet of notes that we're going to look at. review of what a function is. Did you not get one? I even thought I gave Holly an extra one. Talking and collecting and counting. A little too much for a Tuesday. Sorry for that. Alright, so we're going to look at a function, kind of review what that means, what discrete and continuous mean, and then also talk about domain and range. And then we're going to try and look at graphs and determine if a graph is a function, if it's continuous or discrete, and what the domain and the range of the graph would be. So, does anybody remember what a function is? Julian, what's a function?
It's an expression where each input has a
Yeah. Oh, there we go. Now it's written 5 times. And he said an expression, and I'm just going to say relation. Where each input has exactly one output. Bless you. So 1x to 1y. If an x has 2 different y's, if it's paired with 2 different y's, then we would say it's not a function. We did a test, the vertical line test. You draw vertical lines. If it passes through your graph once, it's a function. But if that vertical line passes through your graph more than once, then we would say it's not a function. You just put it right there. Thanks. All right, other 2 words. And you saw these 2 words last week when we were doing the activity with your shoe size versus the length of your forearm. Discrete versus continuous. So if we have a graph that's discrete, what does that mean? Connor?
The points are scattered or not.
Yeah, that's a good word to use, buddy. So points are scattered like a scatter plot. Or they're not connected. So they're just points. They don't connect to make a line or a curve. It's just points that are scattered. That's what discrete means. So discrete is separate. It's not a group of points that are connected together. Therefore, continuous is a smooth line or curve. There are no breaks in that line or curve. That means everything is connected together. One point is connected to the next point, which is connected to the next point. So function each x has 1 y. Discrete is just a set of points. Continuous is a smooth line or a curve where they're all just connected smoothly together, one to the next. So it doesn't have to be a line. It could be a curve depending on the graph. So what we're going to look at today are those 2 things, and then on top of that we're going to try and focus on the domain and the range. So when we talk about domain, and I know we briefly described domain at the beginning of the chapter, which seems like a long time ago at this point, because it was about 3 weeks ago when we started the chapter. Does anybody remember what domain was? Emma, do you remember? Yeah, so the domain would be all of the input values or the x values represented by the graph. by the function, by the equation, whatever we have. We're going to use inequalities to describe our domain. So, then if we look at the range, Melanie, what do you think the range is? So if the domain are the input values, the range would be,
The output.
yeah. Which are the y values. Again, represented by the graph. And we will be using inequalities to describe those as well. So those are the definitions. I passed out a packet that has a ton of graphs on it. There are a lot of graphs. We're going to see how many graphs we can work through on the front of this. Let's just kind of go through examples to determine if it's a function, if that function is discrete or continuous, and then the domain and range of the graph. And we're going to just start on the front. So using these definitions, we're going to try and see if we can figure out what the domain and the range would be for any given graph. So it wants us to state the domain and the range for each graph. Tell whether the graph is a function, and then if it is a function, state if it's discrete or continuous or neither. So only if it's a function can it be discrete or continuous. If it's not a function, then we're not going to worry about it. So if you look at number 1, let's worry about the function part first. Is number 1, we just have some points here, is it a function? Maggie, why not?
Because there's 2 points and so.
Yeah, so right here, if you look at drawing a vertical line, there are 2 points that would lie on that vertical line. So 2 points on a vertical line means it's not a function. If this were a function, it would be discrete because it's just a set of points. But it's not a function, so if it's not a function, it doesn't get to be discrete or continuous. Okay, so that's the first part. We said the domain were all the x values. Because this is discrete, or because it's just a set of points, we're just going to list the x values that your points touch. That's what your domain is. Any x values that the points touch in the graph. So, Mackenzie Myers, what would the domain be? What points do our graph touch in number 1?
-3,
So, -3 for x,
-2,
-2,
1,
and 1.
and
And then what?
4.
And 4. So there are 5 points here, but we only have 4 values for the domain because one value is there twice. One x value is at a +3 for y, and that other x value is at a -2 for y, but you only write it once. We're going to put these in set notation because it's just this group of points, and set notation puts those little squigglies around it. And that just says all of those points represent the domain and they're included together. So So it kind of just groups them together. I like drawing those little squigglies. I don't really know what they're called besides little squigglies, but I think they're kind of fun to draw. So that's it for the domain for this problem. Now let's look at the range. The range would be all the y values. So again, try and list them from least to greatest, from like what they start on the bottom to where they move vertically. Brock, what do you think for the y, for the range?
-4, 5, 3, -2, and 0.
Erase here. Okay, so we have -4, -2, and then he told me a 0, and then a 3, and a 5. So domain would be the x values, the range is the y. And you're listing just the x and the y separately because it just goes from one point to the next. And that's all we have to do for that problem. Question. Okay, let's look at number 2. Is number 2 a function? Julia?
No,
No, why not?
we do the vertical line test, 2 points of touch on the line.
Yeah, so if we do the vertical line test, lots of places here, 2 points touch. Alright, so now we have to try and decide what the domain is. The domain is the x values that it starts at and it stops at. So like what x values is it stretching in between. So find the first x value, find the last x value, and then it stretches in between those two x values. So we're going to try and write it as an inequality. So Julian, what's the first x value that it touches?
-3.
-3. So we got -3 is where it starts. Julian, what's the last x value on the right that it touches? 3. So it starts here at -3. It stretches over. Yes, it does some kind of funky thing here. We got a pentagon, but that doesn't matter on the shape. We're just looking the distance that the x is stretching, and it stops stretching at +3. So it starts at -3. It goes to +3. The way we're going to write our inequality is by placing an x in the middle, because my x values go from -3 all the way up to +3. And then we're going to place inequalities there. So x is in the middle. X is greater than or equal to -3 because it's bigger than -3. It's moving to the right. But it's less than or equal to +3 because it's not going any further past +3. So it starts at -3. I have stuff all the way up to +3, but nothing after +3. So that's why it says less than or equal to there. Question. Okay, so let's look at the range. The range are the y values. When you read a graph, you read it from the bottom to the top, just like you read a graph from the left to the right. So if you start at the bottom, what's the first value, the lowest point of the range? Julian?
-4.
-4. Julian, what's the highest value of the range? And then your inequality symbols are going to go exactly the same way. So if you start with the smallest number and go to the highest number, your inequalities will always point the same direction. We place a y in the middle this time because we're talking about range. And the range is moving up and down. These represent the y's. So -4 is less than or equal to y, which is less than or equal to 3. Questions? Alright, so let's look at number 3 here. We're going to try and do the domain. Let's start with that. Domain is x. What's the first x value on the left that it starts with? How far does it move to the right? So Holly, what's the first x value on the left that it's starting with? Did you say -4? And then Holly, what does it mean if there's a little arrow on the end of the graph on the right? It continues. If it continues forever, what number do we know that continues forever? What number do we use to represent something that goes on forever? There's a number. Julie? Infinity. Because we don't know what forever is. We don't know where it stops. There is a symbol that we use to represent infinity. Holly, do you know? Yeah, it's like the 8 that got like lazy and decided to take a nap, or a snowman that decided to fall over. So it's that like little sideways 8. That's an infinity symbol. So if a graph goes on forever, it doesn't stop, it goes to infinity. Now we need to make our symbols. This is an open circle. When it's an open circle in a number line, what does that mean about that graph?
Does not include that point.
Yeah, it doesn't include that point. So instead of saying less than or equal to, we just put the less than sign. And then we have x. And then it's less than infinity. It doesn't equal infinity because infinity isn't actually a number we know. So we're going to put a less than infinity as well because it's not like, we know it's not going to be equal to that, whatever that point happens to be. Questions? Okay, let's try and do the range. So looking from the bottom to the top. Garrett, what's the lowest y value of this graph?
That would be 1.
1, yeah. So the lowest point is right here at this horizontal piece, which is just 1. And then Garrett, the right side has an arrow that says it continues forever.
So it would be
So it would also be infinity. Now, when you look at 1, does 1 have a solid point or an open point, Garrett? Solid. So that gets the less than or equal to. Anytime it's solid, it's less than or equal to. Range is y. Infinity is never equal to. So we would just say less than infinity. Questions? Is this one a function? Does it pass the vertical line test? Yes. It passes the vertical line test. Questions? So I know we only did 3, but what I would like you to do for homework is to finish this page. So I believe there are 6 more problems on this page. And then if you flip it on the other side, just do the back of that page as well. Some of them are a little tricky. There's really not any work, but you're looking at the graph. So I'd like you to finish this page, please finish it, and just do the back of the page. Tomorrow we're going to work more with domain and range. I also have a partner activity that we're going to do to try and work on domain and range as well. Questions? We'll put your homework assignment in. Have an awesome day.